Our next example is negative 3 over 6 1/3 plus negative 2 over 6 1/3. First of all, what is 6 1/3 approximately equal to? Well, 6 1/3 is about 6.333333. How do I know this? Well, if I were to solve 1 divided by 3, which would be a third, but if I were to solve 1 divided by 3 using long division, that would be 0.33333 going on forever and ever and ever. Also, you may wonder, how can I visualize 6 1/3 being the denominator? How can I see that? Well, in this case, I'm going to use a circle to represent 1. Therefore, I'm going to need 6 1/3 pieces to make up the circle. I have 1 piece, 2 pieces, 3 pieces, 4 pieces, 5 pieces, 6 pieces, 6 1/3 pieces. I would like to note that this tiny piece is not 1 over 6 1/3. Why is that? Well, it's not a full piece in the first place. It is more like the leftover. It is a third of a piece. I would also like to note that 6 1/3, which is a mixed number, a mixed fraction, is equal to 19/3, which is an improper fraction. Let me quickly explain why by using toothpicks. So I split up each whole part into 3 parts. So let's count how many thirds we have now. 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3, 10/3, 11/3, 12/3, 13/3, 14/3, 15/3, 16/3, 17/3, 18/3, 19/3. And all we did was simply add toothpicks. So therefore, 6 1/3 is equal to 19/3. So why would all this matter? It means that we're not only solving a problem of negative 3 over 6 1/3 plus negative 2 over 6 1/3. We're also solving a problem of negative 3 over 19/3 plus negative 2 over 19/3. It does not matter if the denominator is a mixed fraction or if it is an improper fraction, as both 6 1/3 and 19/3 have the same value. We're solving the same problem. Also, we could have negative 3 over 6.3333 going on, plus negative 2 over 6.333 going on forever and ever. Again, we're still solving the same problem. It does not matter if the denominator is a fraction or if it's a decimal. It still has the same value. Let's now actually solve this problem of negative 3 over 6 1/3 plus negative 2 over 6 1/3. First of all, let's get negative 3 over 6 1/3. Negative 1 over 6 1/3. Negative 2 over 6 1/3. And negative 3 over 6 1/3. To note, in this case, red represents negative. Now, let's get negative 2 over 6 1/3 more. Negative 1 over 6 1/3. Negative 2 over 6 1/3. Now, let's figure out what the total is. Negative 1 over 6 1/3. Negative 2 over 6 1/3. Negative 3 over 6 1/3. Negative 4 over 6 1/3. And negative 5 over 6 1/3. Therefore, negative 3 over 6 1/3 plus negative 2 over 6 1/3 is equal to negative 5 over 6 1/3. The first thing I would like to note is that it is very similar to a problem of solving negative 3 plus negative 2 if I use counters to solve it. The only difference was that everything was over 6 1/3. Therefore, to solve this problem, you add the numerators but keep the denominators the same. I would now like to show how we can know that -3 over 6 1/3 plus -2 over 6 1/3 is equal to -5 over 6 1/3, but without using a model. We do not know that this is true yet. We are trying to show that this is true, and that is what the question mark represents. First of all, I'm going to exchange 6 1/3 to 19/3. How do I know that 6 1/3 is equal to 19/3? Well, 6 1/3 is equal to 6 plus 1/3. 6 is equal to 18/3 because 18 divided by 3 is equal to 6. Now we can add these two fractions because they have the same denominator and both their denominators and numerators are positive integers. We add the numerators but keep the denominators the same. 18 plus 1 is equal to 19 and the 3 stays the same. So we still do not know that the second equation is true. Now I can work with the -3 over 19/3. That would be equal to -3 over 1 over 19/3. -3 divided by 1 is equal to -3. Why is that? Anything divided by 1 is equal to that anything. Now I can write the division sign in a different way. The lines in fractions means divide, and we just simply wrote it in a different way. -3 over 1 divided by 19 divided by 3. When you divide two fractions, you do keep, change, flip. I plan to later explain why this is the case in a future set of videos, and when I create the future set of videos, I plan to link it in the description of this video. So anyway, we keep the first fraction of -3 over 1. We change the sign of divide to a multiply, and then we flip the second fraction. To multiply two fractions, you multiply both the numerator and the denominator. Why can we do that? Well, I plan to explain why in a future set of videos, and then attach that link in the description of this video when I publish that future set of videos. And then we simplify that as -9 over 19. When I have this sort of fraction, I like to think it as so. Bring the bottom number to the top. And that reason why I can do that was shown in the previous yellow box. And then that would be equal to -9 over 19. So anyway, I can exchange the -3 over 19/3 to -9 over 19. I can continue this pattern for the other two fractions. And actually now we do know this is true. We do know that if we have numerators and denominators with positive or negative integers, that you can add fractions this way. Add the numerators but keep the denominators the same. Because we know the last line is true, we know the middle line is true, and that the first line is true. Therefore, we now know that -3 over 6 1/3 plus -2 over 6 1/3 is indeed equal to -5 over 6 1/3. The next video in this set of videos is part 7D, which is the fourth example for this case when you include non-integer denominators. If you would not like to watch any more examples for this case, feel free to click on the second link, which includes part 8, which includes when you have a numerator of 0, and it also includes part 9, which includes when you have a denominator of 0.